Welcome to the next episode of the Version Control with Git series. In this episode, we've been working on a repository called Planets. In that repository, there's a few files. The two that are version controlled are the mars.txt file and the analysis.py. We also learned how to ignore particular files. If we look at our history, we can type git log --1 line. We have a series of about 8 commits here from the previous videos that were part of this series. Everything we've done so far for using version control with Git has been on our local computer. So this is on my computer or whatever computer you've been working on. You've been creating a folder with a history to it that creates a repository. Oftentimes, people host these repositories on a service called Github. There are others such as Bitbucket or GitLab as well. GitHub is probably the most popular, and it's the one we'll talk about in this series. GitHub uses Git, and it's a place to host Git repositories. It has a lot of features, some of which are free, some of which are paid. Everything we'll be doing in the next part of this episode will be using the free tier of GitHub. Here I'm logged into GitHub with my user account. And the first thing I want to do is I want to create a placeholder here on GitHub to connect my local repository. So we already made this Planets repository on my local computer, but I want to put that on GitHub. And so to do that, I'm going to start by clicking this plus button here and clicking New Repository. Another way you can start a new repository is to click this new button here. Again, I'm signed into my account. These options won't be visible until you're signed in, but there's a new repository button here, and then the plus button, and then you can click new repository is another way to make a new repository. And this is kind of making the placeholder for the repository on GitHub. And since I already have a repository, then I can connect it. I could have also started out making my repository on GitHub and then moving it to my local computer. In our case, we have an existing repository, but both are options if you decide you want to start your repository on GitHub. Here, I could give my repository a different name on GitHub than it has on my local computer, but I'm going to make it match and I'll call it Planets. I can also write a description, so I can write a little bit more about this particular repository. I'm going to say this is a test repo for learning how to use Git and GitHub. You'll notice I have a few organizations I belong to, and so I get an option for a drop-down menu here. And so you can have repositories belong to organizational accounts as well. So if you have an organization and you want to collaborate together, you can create an organizational account, and you could create the repository under that organization instead of under an individual user's account. I'm going to create this one under my user account though. I believe if you want to have collaborators, you need to pay to use the private tier, but GitHub has changed their pricing model in the past, so I may be wrong about that. But if you're working by yourself, you could use either public or private for free. I'm going to go ahead and make this public. I like to default to public unless there's a reason to keep something private. If it has information that needs to be kept private, I will make a private repository, but I default to the public option. And then you'll notice here it says initialize this repository with, and then it says skip this step if you're importing an existing repository. And so since we're importing an existing repository, we will skip this whole section here. If we were starting with a new repository and we didn't have one on our local computer, we might want to go ahead and add a README, start out with a git ignore, and think about a license for our software as well. But since we already have a repository, we don't want to have 2 histories of Git going on, one in GitHub and one in our local computer. And if we click these buttons, it'll do that. And so since we already have an existing repository, we're skipping this section. And then I can go ahead and click the Create Repository at the bottom of this page. All right, here it gives us some hints on how we can do the setup. So it gives some recommendations of commands. I know these and we'll be going through them, and so I'll go ahead and not read them out loud. But here's where there's a couple options. Since we went ahead and set up SSH keys, I want to make sure that I have the SSH button clicked here. If I was using a personal authentication token instead, I would probably want to use HTTPS. But since I set up my SSH keys, I want to use the SSH key option. And so the address should look something like git@github.com, and then your username, and then planets.git. You can highlight it and copy it, or click this copy button at the end because I'm going to need that pathway. I'm going to need that address to connect it to my local computer's Git repository. So let me switch back to Git on my local computer here. All right, if I want to set up a connection, so I want to tell my local computer about the address on the web, so I can type git remote. And so remotes are any remote connection to a repository. And so that repository I set up on GitHub is a remote. I could have other remotes for different copies of this repository on GitHub or other things, but we're going to start out with one remote and we'll say git remote add. So we have to tell it we want to add a remote. And then here we have to tell it what to call that remote as the next argument. The default name for these, for most repositories, to the first connection you have is called origin. That's what, if we were to set it up a repository on GitHub and then put it on our local computer, commonly the remote setup would automatically call it origin for us. We could call this whatever we want. Maybe we want to call it, my GitHub, my fork, or whatever connection makes sense to us. But typically origin is going to be the name that is most commonly used. And then we'll paste in the address that we set up that GitHub remote at. You can go ahead and press enter. Now if I type git remote and type -v for verbose, it will tell me about the connection I just set up. And it says I have an origin connection where I can both fetch and push. So it sees that origin connection now. It's not necessarily a connection so much as letting it know what the address is for that particular repository that I created in GitHub. All right, so the next thing I need to do is sync the history of what I have on my local computer with GitHub. So here, let's just go back for a second and check out GitHub here. You can see it doesn't have anything except for those, even if I reload, it doesn't have anything but those quick setup instructions. So it doesn't have any of the history. It doesn't have any of the files that I've created on my local computer yet. I've just told it the address of this GitHub repository. And so now I need to sync it. And so when I want to sync my local changes with GitHub, I can do what's called a push. So I'm going to push those changes and that history and those files from my local computer to GitHub. And so I'll say git push origin, and then I need to tell it which branch to push, which is the main branch. When you only have one remote and one branch, you could type git push by itself without the additional options. However, I like to be explicit to make sure I know which remote I'm pushing to and which branch I'm pushing. And so I'll always write out the remote name and the branch name. So here you can see some information about it pushing. If it hadn't worked, we would have gotten a warning or an error message here telling us that something went wrong and it wasn't able to push to the origin remote. If we go back to GitHub, and I reload the page again, now we can see all of the history and all the files that were version controlled on my local computer. So you'll note that those data files in that results folder are missing, and that's because they're ignored. They're not in the history, so they didn't get pushed to GitHub as well. You'll also note that you can see the history of commits. You can see the last time I committed. There was a little break between the last time I recorded a video and this video's recording, so there were 7 days between. You can also see the history of the commits. You can see that, and if I click on that commit button here, I can see all of my commits and their commit hashes and the commit messages and the name of the author as well. To get back to the main part of the repository, there's a couple of options. I can click code or I can click on the repository name. Both will take me back to this main page that shows me the files in my repository and when they were last edited and the last commit message from them. There's a lot of other options that we can see in GitHub here. There's options for filing issues. So if you want to make a list of things that need to be improved or other people find something that needs to be improved, they can file an issue. We'll also talk more about pull requests where we can collaborate together on a project using pull requests. And there's a few other tabs in here that can be really useful. I won't cover the middle ones here, but settings is also something that you'll be interacting with a lot because it has the settings for the repository. And so if you wanted to delete a repository, if you wanted to rename it, both of those things you need to be careful about, but are possible in settings. If you needed to add a collaborator or other things directly to this repository, all of those options are under settings. Let's also see how to get changes from GitHub back down to our computer. So if we had this repository on multiple computers, say we had one on our laptop and one on our desktop's at work and our laptop's at home, and we can have the repository in both places, and we can use GitHub as an intermediate to sync between those two locations. And so after we're done with work, we can push all of our changes to the GitHub repository, and then when we come home, the next day we're working from home, and so we can pull to our laptop, start with the same changes that we have from the day before. Somewhat intuitively, the command to get changes from a remote is git pull, so the opposite of a push, origin, and then the name of the branch. So we need to give it our remote and name of the branch. And if I type that in now, it says everything's already up to date. And that's because I haven't made any changes to the repository since the last time I saw it. So let's make a setup here where we pretend like we have two computers, and we're going to have two copies of the same repository on our computer here, but we're going to imagine that they're in two different places. And so right now, if I do pwd, I'm in the planets repository on my desktop. I'm going to type cd to get back to my home folder. Now that I'm back in my home folder, I'm going to create my laptop. So I'm going to type mkdir laptop. And I'm going to cd into the laptop folder. So here we can imagine that we move to a new computer, we have our laptop, it doesn't have anything on it, it might have other things, but first thing we want to do is we want to get that project, that planets repository, onto our laptop. And to do so, we need that same address. So we can go back to our Git repository here, and we need to copy the address that this repository is at. We can do so under this code drop-down menu here that's green. And we want to, again, make sure that we're using the SSH one because we've set up SSH keys on this laptop as well. So you could imagine we've gone through the configuration and SSH keys set up already on that laptop. And so we want to make sure we copy the SSH address. We'll go ahead and copy it. And then here we're going to run a command called git clone. And this is going to clone our repository from GitHub onto our local computer. And so it's going to create a folder for us, set up that remote origin connection, and pull down all the files for us, all in one command. So we can type git clone, and then we paste in the URL. If I wanted to rename the folder, I could add additional argument here saying new name, whatever I would like to call the folder, but I'd like it to still be called planets on my laptop as well. So I'll go ahead and run that. You can see it says cloning into planets. So if I type ls, you can see that it created the planets repository. If I cd into planets, we can see where I'm at. So I'm, again, not on the desktop version, not the version that we originally created, but I'm on the version in my imaginary laptop here. And if I type ls, I can see that I have analysis.py and mars.txt. Again, I don't have the data files or the results because those were not in my GitHub version of the repository. I did not version control them, and so they never get transferred from my desktop to GitHub or from GitHub to my new laptop. Okay, and so for this, now that we have it, we can make some changes. Well, let's also check our origin. So if we type git remote -v again, here we can see that it automatically set up that origin connection for us. And it doesn't matter what we called it on our desktop, since we used git clone, it made the address that it cloned from to be a remote named origin. All right, let's make another change to mars.txt while we're on our laptop here. So we'll type nano mars.txt. We need to add yet another line to the mars.txt file. Here we'll add a note about the next planet we're going to explore. We'll say, let's explore Venus next. And we'll go ahead and exit with Control X. We'd like to keep the same name with Y and then return. And just as we've been doing over and over again in this series, we're going to add and commit the new changes. So we'll type git add mars.txt, git commit -m, added plans for future exploration. So now if we look at our history, we can, if I hit, well, first if we look at the mars.txt file, if I cat mars.txt to the screen, you can see I have a new line. And if I look at my history with git log --1 line, I can see I have my newest changes. You can see these other changes listed here. That's actually showing us that the origin branch is slightly behind of our main branch. So we have new changes on our laptop that we don't yet have on GitHub. So if I switch back to GitHub here, can hit reload, you can see mars.txt hasn't changed. And if I click on mars.txt, I can see it still only has the last line about Yeti. And that's also true on my desktop, and we'll see that when we switch back to our desktop. But before we go back to our desktop, before we go back into work, we will need to sync those changes. So it's really good practice whenever you start working on a project again to make sure you pull down the latest changes when you start working on that project, and that when you're done, you push those changes so that you're sure that you have the latest version when you switch between different computers or start working on that repository again. Otherwise, we risk the chance of getting those merge conflicts and not having the latest changes, which is something we know how to fix, but something we can avoid in this situation. So we'll type git push origin main. So we're going to push again to that origin connection, and we're going to push the main branch. Now if I switch back to GitHub, it doesn't look like anything's changed, but if I reload the page, I can see now I have a commit from 2 minutes ago, and I added exploration for future exploration, or added plans for future exploration. And if I click mars.txt, I can see I now have the new line, and I actually added a blank line as well. So now those changes are all on GitHub. Now we finish work for the day, and the next day we go back into our office, and we are working with our desktop there. So we need to switch back to the desktop version. So again, we're in laptop, and so we need to cd my desktop is in my home folder. So home folder with the tilde, desktop /planets. Now if I type pwd, I'm back in my desktop, which we can imagine is that different computer. And if I type cat mars.txt here, I can see that it doesn't have my last line. It hasn't synced with the GitHub because it doesn't do it without our permission. We have to explicitly tell it whenever we want it to push changes from our local computer to GitHub, or if we want it to pull changes from our GitHub to our local computer. And so we should do that to update our Git repository here. So we can type git pull origin main. Right now it's pulled down. You can see some messages about the update. It even tells us that same fast forwarding message about 2 additional lines added to mars.txt. Now if we cat mars.txt, it should have the latest changes here. And so this is an example of syncing the different syncing a single GitHub repository between multiple locations. This could be used in a variety of different ways. It could be you have multiple computers. It could be you have a server that you're working on that you have a GitHub repository on and your local computer. So maybe you write your code, test it on your local computer, and then you push it to the server and run it on all your big files and lots of data. And so there's lots of options there. You might just be working with a single GitHub, just making sure that you keep it in sync with your local computer and having GitHub as a backup and a way to publish your data. So that's also possible. So then you'll be pushing and pulling. And also keep in mind that you might also be working with collaborators. That's also where making sure you pull down the latest changes is important. If your collaborators may have changed something, you want to make sure you're starting with the latest version whenever you go to work with a particular repository. This is the end of the GitHub episode on the version control with Git series based on Software Carpentry's Git Novice lesson. The next episode, we'll learn more about how to collaborate using GitHub, and we'll continue on there. So please go on to the next episode to learn more about collaborating with GitHub.